Hello everyone, good evening. Good evening everyone. So this is the QR code of my compiler design textbook. You can buy this textbook from PW store. It will be helpful for BTech, MTech and GATE. Okay. And this is the QR code of my Telegram channel. You can join the Telegram channel for any discussions, right? You can join the Telegram channel for any discussions. Okay. And we are discussing context-free languages. Yesterday we were discussing context-free languages. Yesterday we have discussed ambiguity in grammars. Okay. Today we are going to discuss ambiguity in languages. Okay. Today we are going to discuss ambiguity in languages and membership. And ambiguity in languages is different from ambiguity in grammars, right? So for a given grammar, for a given language, context-free language, there can be infinite number of grammars. Now, if all the grammars that are possible are ambiguous, then we say that the language is ambiguous. If there is at least one unambiguous grammar for a language, the language is said to be unambiguous. Right? Right? Okay. Ambiguity of languages. This is different from ambiguity of grammars. Ambiguity of languages is different from ambiguity of grammars. Right. A language can have infinite number of grammars. A language can have infinite number of grammars. If all the grammars if all the grammars if all the grammars of a language if all the grammars of a language are ambiguous if all the grammars of a language are ambiguous, then the language is said to be ambiguous. Then the language is said to be ambiguous. Right? There are very few ambiguous languages. There are very few ambiguous languages. There are very few ambiguous languages. Ambiguous languages are also called ambiguous languages are also called inherently ambiguous languages. Ambiguous languages are also called inherently ambiguous languages. Right? So, I'll give you a grammar. Tell me about the language. Is this grammar ambiguous or not? A derives AA or AB. A derives B. B derives B. Tell me about this grammar. Is this grammar ambiguous? Tell me about this grammar. Is this grammar ambiguous? Tell me whether this grammar is ambiguous. Hi Prashant, good evening. Very good. So, this grammar is ambiguous. Okay? This grammar is ambiguous. S may derive AA, A may derive a B, or S may derive AB, B may derive a B, right? Therefore, AB is generated in two ways, two parse trees, right? Tell me about what is the language. Tell me about what is the language. This language is ambiguous, but what is this actual language generating? But what is this actual language generating? This language is ambiguous, but what is this actual language generating? What is this actual language generating? Very good. So the actual language generated is AB. Language equal to AB, only one string, right? So for this one string, I could write a grammar A derives AB. Now this grammar is unambiguous grammar, right? For this language, there is a ambiguous grammar and there is a unambiguous grammar. If there is at least one unambiguous grammar for a language, we call the language as unambiguous, right? Therefore, this grammar is unambiguous. This grammar is unambiguous, and so this language is unambiguous. And so this language is unambiguous, right? So how do you check whether a language is ambiguous or not? I will give you rules, okay? I will give you rules to check whether a grammar is ambiguous or not, right? To check if a language is to check if a language is ambiguous or not. To check if a language is ambiguous or not. Ambiguous or not. How do we check if a language is ambiguous or not? Right? Rule number one is L should be Rule number one is L should be union of L should be union of two or more languages. L should be union of two or more languages, which means L should be union of L1 union L2 union L3, so on, 2 or more languages, right? For example, A power n, B power n, C power m union A power n, B power m, C power m. These two languages are different languages. These two languages are different languages, right? So this is A's and B's are equal. This is B's and C's are equal, right? These two languages are different languages. So rule number 1 is a language should be union of 2 or more languages, right? And rule number 2 is this L1 union L2 union L3, whatever, how many ever languages are there, should not collapse into a single language. Should not collapse into a single language. If they collapse into a single language, then the language is unambiguous. If they collapse into a single language, then the language is unambiguous, right? For example, tell me what is this? A power n, B power n union A star, B star. Tell me what is this? A power n, B power n union A star, B star. A power n, B power n union A star, B star. Tell me what this is. A power n, B power n union A star, B star. Very good. So A power n, B power n union A star, B star equal to A star, B star, right? If you observe it, the languages, both the languages collapse into one language, right? So if the languages collapse into one language, then the language is unambiguous, okay? For ambiguous languages, the languages should not collapse into one language. One language. And the third rule is L1 intersection L2. Let us say if L equal to L1 union L2, let us say L equal to L1 union L2, then L1 intersection L2 should not be equal to 5. L1 intersection L2 should not be equal to 5. That should be equal to infinity. L1 intersection L2 should not be equal to 5. That should be equal to infinity, which means intersection of two languages, there should be infinite number of strings. Intersection of two languages, there can be infinite number of strings, right? So what does this mean? What is the meaning of these three rules? What is the meaning of these three rules, right? So if you have L equal to L1 union L2 union L3, then when you write the grammar is going to be S derives S1 or S2 or S3, because they are not collapsing, we have to generate them separately. They are not collapsing, we have to generate each language separately. Now S1 derives L1, S2 generates L2, S3 generates L3, S3 generate L3. Now if I take intersection of any two languages or all the languages, if the intersection is equal to infinity, then what that means is between two languages there are infinite number of common strings, and those common strings can be generated by either using S1, S2 or S3. S1, S2 or S3, right? If they are finite, then what happens? if they are finite, right? Let us say if intersection is finite, if intersection is finite, right? Let us say intersection is AB, BA, okay, some finite number of strings. Then what happens is I can remove AB, BA from S1, S2, S3 and I can place AB, BA here, right? If they are finite, I can place them in the S production and remove them from S1, S2, S3. So there will be only one way to generate those intersection languages. If they are infinite, I cannot put them all in the S production because then that will become infinite number of productions, but number of productions are finite. But number of productions are finite. But number of productions are finite. Right? Right? Okay. Tell me about this. Is this an ambiguous language? A power n, B power n, union A power n, B power 2n such that n is greater than or equal to 0. Tell me if this language is ambiguous language. Yes, Lepakshi, good evening. Good evening, yes, Lepakshi. Tell me whether this language is ambiguous. Apply the 3 rules, okay? Apply the 3 rules I told you and tell me whether this language is ambiguous. Apply the 3 rules I told you. Prashant, what is the reason that is ambiguous? What is the reason that it is ambiguous? Can you tell me the reason why it is ambiguous? You cannot apply one rule. You have to apply all the 3 rules. You have to apply all the 3 rules. You have to apply all the 3 rules. You cannot apply one rule. You have to test all the 3 rules. If all the 3 rules are satisfied, then you can say that it is ambiguous. Yes, Prashant, it is necessary to follow all the three rules for ambiguity. It is necessary to follow all the three rules for ambiguity. So what is rule 1? Rule 1 is L should be equal to union of two or more languages. Here there are two languages. L should be equal to union of two or more languages. Here there are two languages, right? And what is rule 2? Rule 2 is they should not collapse. L1 union L2 should not collapse, right? Yes, they don't collapse. You cannot write them as a single language. They are two different languages. You cannot collapse them, right? And what is rule 3? Rule 3 is L1 intersection L2, L1 intersection L2 should be equal to infinite number of strings. L1 and intersection L2 should be equal to infinite. What is L1 intersection L2 here? What is what is L1 intersection L2 here? What is L1 intersection L2 here? Very good. So L1 intersection L2 equal to epsilon, which means finite, right? Now if I write the grammar for this, I can write it like this. S derives S1 or S2. Let us say A or B. A derives AAB or epsilon. B derives AABB or epsilon. Now, what is the intersection between A and B? It is epsilon, which means I can generate epsilon like this, or I can generate epsilon like this, right? So you may say that the language is ambiguous. But can you give an unambiguous grammar for this? Can you give a unambiguous grammar for this? Can you give a unambiguous grammar for this? The intersection is finite, right? What you can do is take that intersection and put it at epsilon. Take that intersection, put it at epsilon and remove it from A and B. Take the intersection, put it at epsilon, put it at S. Take that intersection and put it at S and remove it from A and B. And remove it from A and B, right? Try it. Try it, you will get it. Try this, you will get it. Take the intersection and put it at S and remove from A and B. Got it? So the intersection is epsilon and you are generating epsilon in two ways. What you can do is take the intersection and put it at S, which means you can write it like this. S derives A or B or epsilon. Now the intersection I have added to S. Intersection I have added to S because it is finite. I am able to add it. Now from A remove epsilon. So what it will become is AAB or AB, and from B remove epsilon. What it will happen is AB, AABB or ABB, AABB or ABB, AABB or ABB. So this is unambiguous. So this language is unambiguous language. This language is unambiguous language because third rule is failing. Third rule has to be infinite, but this is finite. So third rule is failing. So this language is unambiguous language. This language is not ambiguous language. Okay. This language is unambiguous language. Right? Answer this question. A power n, B power n, union A power 2n, B power 2n such that n is greater than or equal to 0. Right? Answer this question. a power n, b power n union a power 2n, b power 2n. Unambiguous because language collapse. Very good. Okay. So rule number 1 is L is union of two languages. Rule number 2 is it should not collapse. But what happens is if you write a power n, b power n, union a power 2n, b power 2n, this will collapse into one language, a power n, b power n, which means this has collapsed. This has collapsed. This has collapsed, right? So rule number 2 has failed. So the grammar is unambiguous grammar. So the language is unambiguous language. So the language is unambiguous language. So the language is unambiguous language, right? Right? Answer this question. A power n, b power n, c power m, union a power n, b power m, c power m, such that n is greater than or equal to 0. N comma m greater than or equal to 0. Tell me whether this language is ambiguous or not. Tell me whether this language is ambiguous or not. Okay. Try it. It is not very difficult. Tell me whether this language is ambiguous or not. Okay. Tell me whether this language is ambiguous or not. Not very difficult question, not very easy, but you can do it. Okay. With the practice we have, we can do it. Very good. This is ambiguous, right? So what is rule number 1? Rule number 1 is L should be union of two languages. L1 union L2, okay. Rule number 1 is fine. And what is rule number 2? L1 union L2 should not collapse into a single language. Here they don't collapse into a single language. In one language A's and B's are equal. In other language B's and C's are equal. You cannot write it as a single language, right? So L1 union L2 is not collapsing. L1 union L2 is not collapsing. Now what is the third rule? L1 intersection L2 should be infinite, right? L1 union L2 should be infinite. So what is L1 union L2 here? What is L1 union L2 here? L1 intersection L2. What is L1 intersection L2 here? Sir, till now I revised 3 subjects out of 10 and give subject wise full length test of all 3 subjects is completed except TOC. Can I target 70 plus in GATE 2026? Yes, Prashant, you can target 70 plus. We have enough time. Revise all the remaining subjects also. You have enough time. You can get into top 100, okay? It is very easy. Even from now, if you finish entire revision, you will be able to get into top 100 with very good marks, okay? So tell me about this. L1 intersection L2 should be infinite. What is L1 intersection L2 here? What is L1 intersection L2 here? In one language, A's and B should be equal, and in other language, B's and C should be equal. What is L1 intersection L2 in this? What is L1 intersection L2 in this? Very good. L1 intersection L2 is A power n, B power n, C power n, which is infinite, right? Therefore, all the 3 rules are satisfied, and so the language is ambiguous. And so the language is ambiguous. Answer this. If a language is ambiguous, then all the grammars of the language are dash. If a language is ambiguous, sir, after how many subjects revised I have to give full length mock test? After you revise all the subjects, then only give full length test. Otherwise, don't give it, okay? After revising all the subjects only, give the full length test. Otherwise, don't give it. Right? If a language is ambiguous, then all the grammars of the language are dash. If a language is ambiguous, then all the grammars of the language are dash. If a language is ambiguous, then all the grammars of the language are dash. Very good. If a language is ambiguous, then all the grammars of the language are ambiguous. Ambiguous, right? Similarly, you can write it in the reverse. If all the grammars of a language are ambiguous, if all the grammars of a language are ambiguous, then the language is ambiguous. Then the language is ambiguous. Then the language is ambiguous, right? Ambiguous languages are also called inherently ambiguous. Ambiguous languages are also called inherently ambiguous languages. Inherently ambiguous languages, that is ambiguity cannot be removed. That is, ambiguity cannot be removed. Ambiguity cannot be removed. Answer this question. If there exists at least one unambiguous language, if there exists at least one unambiguous grammar for a language then the language is dash. Then the language is dash. If there exists at least one unambiguous grammar for a language, then the language is dash. Then the language is dash. Very good. Then the language is unambiguous. Then the language is unambiguous. Answer this. A power n, B power n, C power m, D power m, union A power n, B power m, C power m, D power n, such that m comma n greater than or equal to 0. Is this language ambiguous or unambiguous language? Is this language ambiguous or unambiguous language? Is this language ambiguous or unambiguous? Is this language ambiguous or unambiguous? Is this language ambiguous or unambiguous? Very good. So, rule number 1 says L should be equal to union of two or more languages. L should be equal to union of two or more languages. And rule number 2 says that L1 union L2 should not collapse. L1 union L2 should not collapse into a single language, right? So here these two languages will not collapse into a single language. These two languages will not collapse into a single language, right? Now rule number 3 says, rule number 3 says L1 intersection L2 should be infinite. L1 intersection L2 should be infinite. L1 intersection L2 should be infinite, right? So in this language, L1 intersection L2 is infinite. Why? L1 intersection L2 is A power n, B power n, C power n, D power n. L1 intersection L2 is A power n, B power n, C power n, D power n. A power n, B power n, C power n, D power n, right? So this is infinite. So all the three languages are three conditions are satisfied. Therefore the language is ambiguous. Therefore the language is ambiguous. Now can you give me the grammar for this? For this language, can you give me the grammar? For this language, can you give me the grammar? For this language, can you give me the grammar? Tushar, old videos are available. Please check them once, okay? Anyway, I'm doing all the videos on Physics Wallah channel. You can follow Physics Wallah channel, okay? You can follow Physics Wallah channel. Yes, Tushar, this is sufficient for your preparation. Give me the language for this. Give me the grammar for this language. Give me the grammar for this language. So we can write like this. S is union of two languages. Let me say X and Y. Let me say X and Y. And X is again union, concatenation of two languages. Now A can be equal number of A's and B's. B can be equal number of C's and D's. Equal number of C's and D's. And Y can be equal number of A's and D's. Equal number of A's and D's, or Z, and Z can be equal number of B's and C's, and Z can be equal number of B's and C's. Z can be equal number of B's and C's. This grammar is ambiguous, okay? This grammar is ambiguous. For example, why it is ambiguous? If you want A, B, C, D, equal number of A's, B's, C's, D's, you can generate by X or you can generate by Y, which means you are getting two parse trees. And so this language is ambiguous. This grammar is ambiguous and the language is ambiguous. And the language is ambiguous, right? Sometimes ambiguity of a sometimes ambiguity is not the problem. Sometimes ambiguity is not the problem of the grammar, is not the problem of the grammar, is not the problem of the grammar. The underlying language may be ambiguous. The underlying language may be ambiguous. The underlying language may be ambiguous. That is, the language is inherently ambiguous language. That is, the language is inherently ambiguous language. That is, the language may be, that is, the language is inherently ambiguous language. Right? Right? So the ambiguity may not be the problem with the grammar. The grammar may be, the language, underlying language may be inherently ambiguous. Right? Okay. So we'll end the session here. We'll continue tomorrow. Okay. Thank you. Good morning and Jai Hind. Okay. Thank you. Good morning and Jai Hind.